just wanted to make a quick video to kind of show the fixturing I'm using for making the blades for the vase and the sharps pieces. Um, it's nothing too fancy, but this is kind of what I would come up with to hold these things, and I'm not really sure what's typical in the knife making community, so I just thought I'd make my own, do my own thing, because the blades are a little bit different. So each of these blades has this little T-shaped profile on the spine that is going to be used to help seat each of the blades into the piece. So the fixturing had to sort of account for that. So what I've come up with is what I think is pretty typical anyway, with just like a little twist. So I have a pinhole here that I'm using that's doing double duty as has an 1/8 inch, just like a dowel pin in it, just a little 1/8 inch dowel pin. But I'm also doing double duty to help me dial in or indicate off of. So that's my 0 point for the fixture. So I have that dialed in already. So I'll just pop that out. So from here, just bring it forward a little bit. So from there, I just typical using pins. My pin. So I'll just throw the pin in, but my pinhole is actually in the X center of the blade. So this is a finished blade. This is both sides machined. The first side of each blade is actually machined just in a vise. So it's just the bar stock held in a vise, and I did machine the first half just straightforward and drilled the hole in the vise, and then I threw it on the 2x72 belt grinder and just did a rough profile. So I'm actually, I've left about somewhere around a 10th to a 16th around the perimeter of this thing for the second side machining to nail down for me. There's no need to go any closer than that. So what I have is just a little bit. I machined this large profile just to kind of give clearance for the back end, and then there's this little step that accommodates the little T-slot foot, and that's machined to a perfect depth, so that will bottom and this face will bottom both at the same time, and that allows me to just kind of pop this right on here, and it's actually seats pretty well. But in addition to that, I made this little nut here. It has a little cam head on it, and I just drilled a hole here, and I just kind of dropped that in there, and I can just kind of use that. I can kind of just turn that cam head, and it actually snugs the blade forward against the indicated edge that I've cut into the fixture. You don't need much on it to kind of snug it forward. So even if there's a little bit of wiggle in the pin, that kind of just snaps it all right out of it and gives me a nice positive edge to keep the blade straight. So it's a nice parallel edge to keep the blade straight. And so I don't need two pins or multiple pins. I just have this to get me on center, and then that base is what keeps the blade square. From there, I'm using just two clamps here and here, and so what I'll do is I'll machine all of this face, save for the face of the T-slot, and then I'll cut the profile, and then I'll cut the hollow grind with a bullnose mill, and then I'll pull out these two set screws, flip the clamps to hold the lower face, and then I'll machine the spine and the face of the T-slot on this side. One thing I will point out is that these, when we're half machined at this point, there's a lot of bend in the blade, so this blade is actually concave at the moment, and that's because when you machine one side of the AEBL, you relieve a lot of tension in that side of the blade, and it kind of pulls the blade up. But when I clamp this, it kind of pulls those faces down. It pulls it down flat, and by the time I'm half machined, I've machined that face, I've relieved enough stress on this side that the blade is very flat. So when I flip them and I machine the hollow grind, everything by the end is already is perfectly flat. So these blades, I've had probably an 85% success rate when they come off the mill being perfectly flat. I've had to tweak just a few of them, but it's actually working out pretty well. But you know, when they go in this step, they're probably off by 15 thou or more, and when they come out, they're perfectly flat because it's a symmetrical machining operation. So you're relieving stress on both sides evenly. But yeah, so that's it. I just wanted to kind of show what I'm working with here and how I'm aligning each blade. The handful of people I've allowed to see what I'm working on have all been sort of curious, you know, what the fixture looks like for holding this sort of, it's kind of an odd shaped blade. It doesn't have the typical location points on it, but yeah, that's it.